All right, before we start chapter 6, which is on properties of exponents, let's see if we can fill in what each of these values raised to the second power, the third power, the fourth power, and the fifth power is. So in other words, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, and 2 raised to the fifth is 32. 3 squared is 9, 3 cubed is 27, 3 to the fourth is 81, and 3 to the fifth is 243. 4 squared, 16, 4 cubed, 64, 4 to the third is, let's see, 64 times 4, 16, 256. 5 squared, 25, 5 cubed, 125, 5 to the fourth, 625. 6 squared, 36, 6 cubed, 216. 7 squared, 49, 7 cubed, 343. 8 squared is 64, 8 cubed, 512. 9 squared, 81, 9 cubed, 729. 10 squared, 100, 10 cubed, 1,000. And even though these are x'd out, 10 to the fourth would be 10,000. 10 to the fifth would be 100,000. 10 to the sixth would be 1,000,000. Tens will have as many zeros as the power. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. And 25 squared, 625. All of these squares, cubes to the fourth to the fifth powers, you are going to need to know by heart. They will come in quite handy knowing them in both of the upcoming chapters. All right, now we're going to look at some of the properties of exponents, and then I also have an example of each. So the first one that we're going to start with is called the product property, product of powers. So that means a to the m times a to the n is the same as taking a to the m plus n. If we actually look at an example, let's say 6 squared times 6 cubed. Well, 6 squared means 2 6s multiplied together, while 6 cubed means 3 more 6s. So I have a total of 1, 2, 3, 4, 5, 6, 6 to the fifth. So the shortcut is to take 6 to the 2 plus 3, which is 6 to the fifth. The next property is called power of a power. That's a to the m raised to the end. Power to power, you multiply. You use the most power possible. Example, 6 squared cubed. Well, that would mean a 6 squared times a 6 squared times a 6 squared. So that is 2, 4, 6, 6 to the sixth. In other words, when it's power to power, it's the same as 6 to the 2 times 3, which is 6 to the sixth. The next one is power of a product. So we're going to have a product, which means two numbers multiplied together and then raised to a power. AB raised to the m means a to the m, b to the m. So an example of that would be 6 times 4 cubed. So it's a 6 times 4, a 6 times 4, a 6 times 4. That leaves me with 3 6s times 3 4s. 6 cubed times 4 cubed. The next one is quotient of a power. So instead of power of a product, it's quotient of the powers. So a to the m divided by a to the n means a to the m minus n. If you notice up here, this was product of powers. When I multiplied, I added my exponents. So quotient means when I divide, I should do the opposite, which is subtract my exponents. An example of that, 6 to the 5th divided by 6 squared. That would be 5 times in the numerator and 6 2 times in the denominator. And if I go through and I reduce this 6 and this 6 would reduce, this 6 and this 6 would reduce, and I'd be left with 6 cubed, which the shortcut would be 6 to the 5 minus 2, which is 6 cubed. And the last one then is power of a quotient. Well, up here, I had power of a product, and then I took each one to the power. This time it's power of a quotient. So I'm still going to take each one in the quotient to the power. Notice it stays a quotient, a fraction. So 6/5 squared. That would be 6/5 times 6/5, which is 6 squared over 5 squared. Since the quotient, I still have that division in it. All right, now let's take a few minutes and let's just examine this. What is 3 cubed? Well, 3 cubed means 3 times 3 times 3, which would be 27. 3 squared would mean 3 times 3, which is 9. 3 to the 1 is 3. What did I do to go down a power each time? I actually took, to get 27 and to get to 9, I had one less power, so it meant take the 27 divided by one of the 3's, which would give me the 9. So then 3 to the 1 would be take the 9 and divide by the 3, which gets me to the 3. So then when I get to 3 to the 0, it means take the 3 and divide by the 3, which is 1. So that means the 0 exponent property, anything raised to the 0 is going to give me 1. Again, anything raised to the 0 is going to give me 1. So 4 to the 0 would be 1. 500 to the 0 would be 1. B to the 0 would be 1. Okay, let's keep with the same idea. If I could decrease a power, so this was 1, divide by 3. Decrease by another power, it is 1/3 divided by 3. That is 1 over 3 squared, which is 1/9. So as we can see here, when we have negative powers, it means to reciprocal your position and make it positive. In other words, a to the negative 1 would mean 1 over a to the positive 1. All right, let's try a few. 3 to the 4th all squared. Well, this is power to power. So that means 3 to the 4 times 2, which is 3 to the 8th. If the number is so large that it is not on your chart that we did, we're just going to leave it as 3 to the 8th. Because without a calculator, we don't need to compute that. So here's my quotient raised to a power. So that means 5 to the 3rd divided by 8 to the 3rd. Notice it's still the quotient divided by. Well, this one I can evaluate. 5 cubed is 125 over 8 cubed is 512. Okay? A negative 2 to the negative 3 times a negative 2 to the 9. Notice both my bases are the same. So I could say my base is a negative 2, and I am multiplying. So that means add your powers. Negative 3 plus 9. That is a negative 2 to the 6th. 6 negatives make a positive, and 2 to the 6th. Well, 2 to the 5th was 32, so 2 to the 6th should be 64. I am going to expect you to know that one too. So here we have a quotient, just like up here in B, raised to a power. So this would be a to the 2 times 3 over b to the negative 3 times 3. So that's a to the 6th over b to the negative 9. Remember, all negative powers reciprocal their position. So this is in the denominator. So to make it positive, I'm going to have to move it to the numerator. So already in the numerator, I had a to the 6th. When I move that up, it becomes times b to the positive 9. All right. Well, this is a negative y squared raised to the 5th. So that's 5 negatives make a negative y to the 2 times 5. That part is a negative y to the 10th. So that took care of this one. I still have negative y to the 10th times y to squared times y to the negative 12. Well, the negative is going to stay negative. My base is a y. I am multiplying all of these. So it would be 10 plus 2 minus 12. That gives me a negative y to the 0. Anything to the 0 power is 1. So this y to the 0 is a 1. And then I still have the negative, so it is a negative 1. All right, let's simplify this quotient. RS squared, that doesn't simplify, divided by. So again, I've got the product to a power. So it means the R will be cubed and the S to the negative 1 will be cubed, so times 3. So that gives me RS squared in my numerator over R cubed S to the negative 3. I'm going to first just take care of my R's. Where do you have more R's? On the top or the bottom? On the bottom. So this will reduce to an r squared. So on the bottom I have an r squared. Right now, this s is not positive. So to get all positive exponents, it reciprocals its position. So this will reciprocal up. So on top I have s squared times s cubed. That gives me s to the 5th on top, because timesing you add, over r squared on the bottom. And then we have just this one last one here. 10 squared, all raised to the 4th, times 10 to the negative 2. Well, this part is power to power. So that is 10 to the 8th times 10 to the negative 2. So my base is 10. 8 plus negative 2 gives me 10 to the 6th. So that would be 1 million. I don't know if you want to try a couple more here. A negative of 2 squared times 2 to the 4th. So that means the negative is out front. It is not in the parentheses. If I wanted it to be a negative 2 squared, I would put it in parentheses. But it is written as the opposite of 2 squared. So I'm going to have my negative, and then it would be my base is 2 to the 2 plus 4. That's my negative of 2 to the 6th. 2 to the 5th is 32 times 2 is 6. So a negative 64. So it would be A. All right, on this one, it looks like first we have the negative 5 cubed. Well, a negative 5 cubed is a negative 125. X to the negative 2 times 3 is x to the negative 6. Times x to the 7th. So this becomes a negative 125. X to the negative 6 times x to the 7th. I add those, so I get x to the negative 6 plus 7. That's x to the 1. Negative 125x. D. Here's a quotient to a power. So first it's 2 to the negative 2. Then it's x to the negative 3 to the negative 2 over 3 to the negative 2, y to the negative 4 raised to the negative 2. All right. So this one, to make it positive, is going to move down in the denominator. So that becomes 2 squared. And when I do this number, to move it positive, it's going to have to go up to the numerator. So that's going to become 3 squared. Power to power multiply, that's x to the 6th. Power to power multiply, that's y to the 8th. So when I evaluate that, 9x to the 6th over 4y to the 8th.